Okay, last week what we talked about was the 5,6 reactions that can occur out there in the real world, but I forgot to give you the sixth reaction. I got so excited about being able to talk about moles that I totally forgot about the sixth reaction. We labeled the five reactions, and we had, what did we have? We had decomposition, we had synthesis, we had combustion, and that's not how you spell combustion. Combustion, we had single replacement, and then we had double replacement. The double replacement. And that was where there's a second type of double replacement. Regular double replacement, we said, looked like this, where we had AB plus CD, magic sign going to AD plus CB. And that was what we said was a double replacement. Well, there's a special kind of double replacement, and it's so special that it warrants its own category, really. That's the sixth reaction that I was talking about, and that is acid-base neutralization reaction, which is just a fancy form of double replacement. But like I said, it's so important that people tend to call it its own double replacement or its own type of reaction. So let me hit that real quick. Acid-base neutralization. There's a whole chapter on this. So if you look at this and say, wow, this is really cool, I really like acid-base neutralization reactions, just realize that in probably 3 months, you will get a whole chapter on acid-base neutralization. Woohoo! So we're going to call this acid-base neutralization. Neutralization. And what this looks like, if we have HA plus BOH, and this A and this B, it can be anything, right? However, this H actually is hydrogen, and this OH is actually OH, oxygen and hydrogen, what we typically call hydroxyl unit, all right? And that is indication of a base. Once you see an OH, you know it's a base. Once you see this hydrogen out in front of something, you know it's an acid. Right? And so an example of this would be, whoops, I forgot the magic sign. Magic sign forming H2O plus Ba. And this Ba would be a salt, an ionic compound. Right? An example of this would be hydrogen bromide plus sodium hydroxide going to NaBr plus H2O. Kind of wanted to give sodium chloride. Let's just do sodium chloride. So sodium or hydrochloric acid, as opposed to hydroboric acid. Hydrochloric acid plus sodium hydroxide forms something that we all know, NaCl, a salt, plus H2O. All right? And we call it a salt. A salt is basically any kind of ionic compound. All right, so this is a salt, NaCl. It's a metal plus a nonmetal. Metal plus a nonmetal. A salt plus water. It will always form water. All right, that's one of the special things about acid-base neutralizations. It always forms a salt plus water, or dihydrogen oxide. Okay, so that's our 5th/6th reaction. And then we went about and we did some balancing, some equations. And then after we balanced some equations, we then we then talked about moles. Woohoo, moles! We love moles. They're so furry and cuddly. That's not the same kind of mole I'm talking about now. What did we say moles were? Yes, Benjamin, what did we say moles were? It was a specific number. Remember, it was how many? It was a certain amount of elements or a certain amount of atoms of a particular element. All right, we said 1 mole was equal to 6.023 times 10 to the 23rd atoms of an element. Atoms of an element. And that is a lot of atoms of any particular element. Then we talked about, what did we talk about? We talked about, I think that's all we talked about. Yeah, that's all we had time for. And so what we want to talk about today is why this mole concept is so important to chemistry. All right, so let's talk about the molar mass of an element. Molar mass of an element. Molar mass. Is this in focus, John? Can they see this molar mass of an element? Kind of. Molar mass of an element is how much a mole of that element weighs. So how much 6.02 times 10 to the 23rd amount of those atoms weigh? All right, so how many, well, that's a terrible way to say that. How many grams 6.023 times 10 to the 23rd atoms of an element weighs, or the mass? Yeah, you hate to say weight. Weight's not the same thing as mass. We'll say mass, but most everybody refers to it as atomic weight. So we'll just go with weight. All right, so what 1 mole of an element weighs, which is equal to the atomic mass of that element, which equals also the atomic mass of that element. Okay, so let's take an example, carbon. What does 1 mole of carbon weigh? What does 1 mole of carbon weigh? What's the mass? I keep using that weigh. What's the mass of 1 mole of carbon? 6.02 times 10 to the 23rd atoms of carbon. What does that weigh? Well, it just so happens that that is on our periodic table. We were using that as the atomic weight, but in fact that atomic weight is also the molar mass. The molar mass of that element. And what is the atomic weight or the molar mass of carbon? Let's look over on our periodic table. All right. So what is the molar mass, atomic weight, atomic mass? All these are interchangeable terms, unfortunately, depending upon how old you are. When I went to school, it was atomic weight, now it's atomic mass. Molar mass, now it's molar mass. But anyway, take a look at carbon. Carbon has an atomic weight of 12.011. That's also its molar mass. So if I had 6.02 times 10 to the 23rd atoms of carbon, it would weigh 12.01 grams. 12.01 grams. All right? Good? Okay, so that's what 1 mole of carbon weighs. What about 1 mole of nitrogen? What would 1 mole of nitrogen weigh? Well, we come over here and look at nitrogen. Nitrogen 14.007. it would weigh 14.007 grams. All right, what else do we got? How about phosphorus? Phosphorus is right here. 1 mole of phosphorus would be 30.973. How about a mole of magnesium? 1 mole of magnesium, 6.02 times 10 to the 23rd atoms of magnesium would weigh 24.305 grams. All right? That's pretty easy. That's an important concept because that concept is going to be the springboard for allowing us to do all kinds of fun stuff. All right? Okay. So we said 1 mole of N2 weighed, are you recording? 14.007 grams. 14.007 grams. 1 mole of carbon weighed 12.01 grams. And 1 mole of magnesium, we said weighed 24.30 grams. All right. So, if I had 3 moles of magnesium, what would 3 moles of magnesium weigh? And I know you're tempted to say, oh, this is a piece of cake. If one mole weighs that, 3 moles is 3 times 24. Nice and easy number, right? But I don't want you to do it that way. What we need to start doing is using the box conversion method, all right? So we're going to say, well, 3 moles of magnesium. Let's see, do we have a conversion factor? Yeah, well, we got this. We got 1 mole over 24.30 grams. 1 mole of magnesium is equal to 24.30 grams. Or we can say it the other way. We can say 24.30 grams of magnesium is equal to 1 mole of magnesium. Right? So we're gonna, which one of these are we gonna use? Can I see what I'm doing here? Which one should I use? I want to end up with grams, right? I want to know how many grams 1 mole or 3 moles of magnesium weigh. So I want it to come out in grams. I'm going to use this conversion right here. So 1 mole of magnesium is equal to 24.30 grams of magnesium. And then we cross out. We're going to cross out moles here. We're going to cross out moles here, leaving us with 3 times 24. And what does that equal? Who's got a calculator? Which of my students has a calculator? Oh, I do, Mr. Sloniger. Thank you. What does 24? I actually don't have a calculator. Who's got a calculator? What's 24 times? 24.3 times 3 is what? Oh my gosh, I can't believe I can't do this in my head. 24.3 times 3 is 0, 9, 12, 50, 52.9? 53.9?
72.9.
Okay. All right. 72. Wow. Okay, very good. 72.9. Oh my gosh. Magnesium. I majored in science because I stunk at math. 72.9 grams of magnesium. And that's, actually, if you're no good at math, you can still become one heck of an organic chemist. Organic chemistry doesn't rely on a whole lot of math, but you gotta know a lot of math to be able to get through chemistry. So if you struggle with math, you can still become a chemist. You just got to struggle all the way through the math and major in organic chemistry, and then you can build all sorts of chemicals that you don't have to worry about math. Kind of cool. Organic chemistry is a lot of fun. Okay, so that is how we convert. How about, what else can we do? We'll keep those numbers up there. We'll just use these. How about what does, how many grams of nitrogen, now let's use carbon. How many grams of carbon are in 5 moles of carbon? Oh boy, that's a fastball. That's a fastball. How many grams of carbon are in 5 moles of carbon? Well, let's see, we're going to use carbon right here, right? And we know 1 mole of carbon is 12.01 grams. What are we going to start with? Well, they're asking us 5 moles. So that's going to be our first number, right? That's what we're going to write down. So 5 moles of carbon. And we want to know grams, right? We want something that's going to end up in grams. So we want something that's going to cancel moles. So we know 1 mole of carbon is equal to how many grams? 12.01 grams of carbon. And my teacher's assistant is busy calculating this for me. So our moles cancel, leaving us with how many grams of carbon? How many grams of carbon, teacher's assistant? 60.05 grams of carbon. And we can do this the other way too. I can give you a number and say, hey look, let's do this. So let's say how many moles are in Mr. Mike's front yard? That's a funny one. No. How many moles are in 120 grams of magnesium? 120 grams of magnesium. Oh my gosh, what are we going to do? Oh no. Well, we're going to start, what are we getting? We're given 120 grams, right? 120 grams of magnesium, so we're just going to write that down. We're not even thinking about 120 grams of magnesium. Now, they want to know moles, right? So we have to end with moles up here. What do we got that's going to enable us? Oh, look, man, we got this conversion factor right here. And we know that 24, we want grams to cancel, 24.30 grams of magnesium is equal to 1 mole of magnesium. And what does that equal? What does that equal, teacher's assistant? 4.938 moles of magnesium. So it's not quite 5 moles. Okie dokie. That's easy. Okay, so that's just basically atoms. But I know what you're saying. Mr. Mike, show us what we can do when we're dealing with real chemicals, when we're dealing with chemical reactions. Okay, I'll do that for you. Since you're so curious, let's just take one. Let's just take a mole of sodium chloride. That acid neutralization reaction we just did, where we had hydrochloric acid plus sodium hydroxide going to sodium chloride plus H2O. Let's take a look at the salt. What would be what would a mole of sodium chloride weigh? 1 mole. What is 1 mole of NaCl weigh? Oh, there's that weight thing. What's the mass? We'll be chemists. What's the mass of mole of sodium chloride? Well, this is actually molecular weight rather than atomic weight, right? Because we said over here, each one on our periodic table, that number below the element's atomic weight. Well, when we add things up, it becomes a molecular weight, right? Because this is a molecule of sodium hydroxide. So to figure out the molecular weight, all we do is add up everything in this molecule. Sodium, what does sodium weigh?
Gee, I don't know, Mr. Swalliger, what does sodium weigh?
It weighs 22.98 grams. 22.98 grams. What does chlorine weigh? Well, chlorine weighs 35.45. So what's its molecular weight?
I don't know, I don't have a calculator.
Teacher's assistant, what? Can you add that up for me? Please? What's it weigh?
Hello? Hello?
58.43 grams. That's its molecular weight. Wow. What does 1 mole of what's this, sodium chloride? Sodium chloride? Yeah, what does 1 mole of sodium chloride weigh? Well, 1 mole of NaCl is equal to 58.43 grams. Man, this stuff is easy. And it's so much fun, too. Is it easy because it's fun, or is it fun because it's easy? I don't know. That's the question. That's the question. I know vector calculus isn't fun. It's hard too. It's hard because it's no fun, or is it no fun because it's hard? It's just no fun. Hey, I'm in the room all by myself, but I'm making myself laugh. Okay, so what would 3 moles of sodium chloride weigh? Well, you know, hey, this is a piece of cake. 3 moles of NaCl. We need to get it into grams, right? We want grams to be up here. What does 1 mole weigh? Well, we said 1 mole. 1 mole equals 1 mole of NaCl equals 58.43 grams of NaCl. And what does that equal, teacher's assistant? 3 times 58.43. 175.29 grams of NaCl. Pretty cool. Let's do some more stuff. Let's do another one of these. We could just do these all night long, but I'm going to run out of film. How about, let's get a nasty one. How about sugar? How many moles, oh, I know a fun one. Oh, okay. How many moles of sugar are in 1 Coke? Are in 1 Coke. Oh, we have a student coming in late to class.
Uh-oh.
Where were you at? Why are you late to class?
My husband was working and I had no transportation.
You're so old already. Come up already. All right. And you're late for what reason?
My husband.
Your husband? This is high school.
I can't drive, so I have to wait for transportation, and my transportation was late.
Do you have a note from your parent? From your parents about
no,
this?
but if you give me a minute, I'll give you one.
All right, go ahead, take a seat.
Let's see, just sit at the table?
Yeah, sit at the table.
At the table.
All right, how many moles of sugar are in 1 Coke? Oh my gosh, how many grams of sugar on a Coke? 350 grams? How many? Anyone got a Coke? I think there's 35 grams. Okay, so there's 35 grams of sugar in Coke. 35 grams of sugar in Coke. What's the molecular weight of sugar? Oh my gosh, I have no idea.
I know what a 10-pound bag looks like.
35 grams of sugar. We got molecular weight of sugar is C6H12O6. Oh my gosh, that's a huge. Okay, so what? Carbon's molecular weight's 12, hydrogen's 1, oxygen's 32. Right, so 6 times 12 is a lot of 1 times 12. Magically, I did this actually before class. I know what it was. It's 180 grams. 180 grams of C6H12O6. All right, so 1 mole of sugar is equal to 180 grams of sugar. All right? Again, for those of you that came in late to class, I can see you're a little confused, and that's why you need to get to class on time.
Yes, sir.
1 mole is 6.02 times 10 to the 23rd atoms of an element. That's a really big number. 6.02 times 10 to the 23rd. We did this on last class, I believe. So times 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23. That's the number of molecules in a mole, right? A lot of molecules. So if I took this many atoms of C6H12O6, it would weigh 180 grams. 180 grams. But the question was, how many moles are in 1 Coke? Okay, so we figured out a Coke has 35 grams of sugar. So what this is asking is how many moles are in 35 grams of sugar, right? How many moles are in 35 grams of sugar or in 1 Coke? Phew. Okay, so we got 35 grams. We're going to start with 35 grams because that's what they gave us. I'm going to erase some of this up here. All right, so we're going to start with 35 grams. 35 grams of C6H12O6. And we want this to end up in moles, right? So we want moles up here. We need something down here that's going to cancel with grams, and it's going to be grams. We know that 1 mole, we calculated this down here, right? Here's the molecular weight. The molecular weight's also equal to what 1 mole weighs, right? So we got one mole of C6H12 is equal to 180 grams. 1 mole of C6H12O6 is equal to 180 grams of C6H12O6. All right, so we're going to come up here, we're going to put 180 grams. 180 grams of C6H12O6 is equal to 1 mole of C6. Whoops! 1 mole of C6H12O6. Teacher's assistant, how many moles is that?
194.
What? Oh, I'm sorry. Yeah, you're right. What is it?
1194.
0.194 moles of C6H12O6. Look at that. There's not even 1 whole mole of sugar in Coke. That means Coke's actually healthy for you. No, probably not. All right. But being able to do this is fundamental to chemistry, right? If you can't do this, major in history. I'm only kidding. If you can't do this, we'll go over till you can do it. It's fairly simple once your mind sort of opens up to it. Okay, that is all I need to cover in today's class. You have a worksheet that's going going to be being sent to you, bringing home this whole concept of moles. All right, so do that worksheet. When you come to class next, you're going to see how we use this mole concept and do something called mole to mole ratios. Oh my gosh, this is the best part of chemistry, really. This next class is going to be a lot of fun for me. All right, well, we have a question. Yes. It's Beth, right?
That's
Beth,
correct.
yeah.
Is the limited age of understanding this? If you never had it.
If you never had, well, did you have chemistry when you were?
No.
It may have went by a term alchemy. Did you take alchemy? Oh, that's mean.
Took religion and I took English.
Did you have biology? You had to take Okay, so you had. Well, you took biology.
Math.
Okay. What'd you do in high school? Besides flirt with the football players. Goofed off. Come late to class.
I was a good student. I was straight A's.
Did you? I can believe that. Ron made straight A's. I never made one B. I never had any B's. I didn't get. How do you say that? I never got any B's. I never got any
No,
B's.
C's.
That's exactly it. Yeah. People just assume when you say that I never got any B's that you made all A's. Wow, you're really smart. No, I'm really dumb. You just got to be able to spin your inadequacies. That makes it sound awesome. I never got any B's. Wow.
Whoa.
Yeah. Yeah. Okay, that's it. Do your worksheet and give me a call if you don't understand it.